All right, so just making a tutorial here for a reference. You can see what the teleporter looks like, and the main thing, the first thing I'm seeing off the bat is that it's an oval shape on a pedestal. The next thing I'm seeing is that it's all flowing downwards. So looking at the reference, we need to kind of recreate something like that. I've already done a tiny bit, but I'll walk you through it. So I've downloaded a model for a pedestal here. I applied a material to it, which is the textures that came with it. If you're wondering what that looks like that. Next thing is I created this circle. Just changed the radius a bit to make it an oval. And you can see there's not many points along this circle. And if I were to do the early to long curve, we get a problem. We don't have enough points. So I just use a resample node, which gives us a lot more points to work with. I go from 13 points to 700. This orient along curve node does a really cool thing, right? Because it creates, out, up, or tangent, right? If I set this to the normals, for example, that's all going outwards. While on this one, it's just pointing in that direction. The one we want to use is the tangent. I'm going to set this to the velocity attribute. And I will bring down the amount of points so I can just see what's going on. So basically, it's going along the curve, and it's kind of spiraling all the way through, like all the way around. Not exactly going down, but I have an idea of how I will fix that. So, that being said, it's about all I have so far. I'll go over this in a second. But first, I want to randomize the velocity so it doesn't always have the same length, right? So I'll drop down a wrangle node, and I will take the velocity attribute, and I'll multiply it. So I'll do multiply equal, and I'll make a float channel, and a float is just a number that can be literally any number. It could be, with any decibel, is literally any number. So I'll do CHF in parentheses. I will, hold on, no, I forgot one part. I want to do a random. So I want to do it random by the point numbers. So ptnum. Forgot one more thing. I want to fit this between two values. So I do fit 01. And I will create a minimum channel and a maximum channel. End it off with a semicolon. And so far, you don't see anything. If I click right here, I can set, the minimum and the maximum here. So this helps randomize the length of the velocity. It helps to make it more tame. Another thing I want to do is, if I do this, you can see the velocity vectors are kind of going through here. And that's not a huge deal if it's going through. It just means it's going to be, hitting the bottom. It's pretty hard. But I don't want it to go all too out crazy hitting the bottom. So I kind of want to minimize the amount of velocity towards the end here. And a way I could do that is using the position attribute. So if I switch this to the right, for example, right? And I can just undo that. I can see that, this lines up right around, 1.3. So if we do an if condition, which allow me to do a certain operation based on a condition, say if the position.y, so the y-axis, is greater than a threshold, so I'll make another channel here, then v, we could just do @v is multiply equal another channel, and we'll call this multiplier. missed a parenthesis there. Right? So far that isn't working, so I think I need to press it. There we go. So I can minimize it. Now I can look. Ooh. I want it to be more like here. Just trying to dial in these values. So the bottom area isn't going to be going as crazy. And I can just dial in these values. I think something like that will be good. So now we have our velocity. Now I'm adding some more things to the velocity here. And what I'm doing is I'm using a point velocity node, which by default is going to override our velocity. We're just going to keep incoming. Then I'm just adding a curl noise and, bringing down the swirl size and bringing down the scale. Other thing I'm doing is I'm creating the offset and having it go down based on time, which will work based on seconds and not frames, right? So, yeah. And then I'm just multiplying it by -2, so it goes downwards. I just have more dialed in values here. And I put that in the wrong area. I'm doing that on the offset, not the swirl size. It's great. Now we got this. So the next thing we need to do is we need to create a smoke simulation because we need something that has a very fluid movement. Because again, the movement here kind of flows. It's not like what flows. So we want to make sure that it has a nice fluid movement. And the next thing we do is we need to make sure that it's going downwards. So we just need to create a density attribute. So I'll do a wrangle and I'll go at density equals like 0.5. Next thing we need to do is we need to convert this into a volume. So we do a volume rasterize attributes. Nothing happens because we haven't selected our density yet. And this creates something called voxels. And what these are essentially 3D pixels. You can kind of see this is very low res. So you can kind of see the edges. We will fix that. First of all, I'm bringing the particle scale down. It looks more like that. And I want to decrease the voxel size, which will increase the amount of voxels. So now it's something like this. Right? But they're essentially a bunch of tiny little pixels. If I do a VDV visualized tree, you can kind of see a basic representation of what voxels are. These little 3D pixels. That's about all you really need to know for right now. We also need to source our velocity. And we'll add some... And we won't add any blur. So we'll drop this down in a null. And what a null is, it's basically an empty layer that doesn't store anything. But if you plug something into it, it stores everything that's plugged into it. So, got that. And we'll name this out src for source. And we'll copy this. Now to create a smoke simulation, let's create a .NET. This is where all simulations happen. And one thing I want to do right off the bat is I want to have this already going by the time we see it. So in the reference, it doesn't form when you first see it. It's kind of already flowing when you see it. And if we, don't pre-roll some of the simulation, it's going to have to form a bit. And we don't want to see that part. We just want to see it moving. So we'll start with a frame rate, right? Start frame -10. Right now we'll set it to 1, just so we can get the simulation going. We need to add a smoke object, We'll do the sparse. We'll do a pyro solver. And we need a volume source. And this is what's going to allow us to source in our volumes. Now, right off the bat, they're not going to see anything, because we're not telling it to create fields. So first off, we need our density. So the source volume is the attribute we put in, so density, and our target field is density. So now we can see our density is being sourced in. Next thing is we need our velocity, so the attribute was v, the target field will be vel. And this is a vector. So, right off the bat, we get this. Let's bring down the voxel size and enlarge fields to contain sources, so we can see our volume. And I'll make the background darker so we can see a bit better. So now we got this, but you'll notice that this isn't colliding with anything because we haven't brought in our collider. So the first thing we need to do is take our pedestal here, and we need to convert it into a VDB, which will work with voxels, because if I zoom in, you can see it's hollow on the inside. And that becomes a problem because there will be errors in the simulation where the smoke will just kind of phase through the object, and we don't want that. But if I were to create a VDB from polygons, plug this in, and I zoom in, well, okay. It still looks hollow, but it's not. This is represented by voxels, and we'll increase the amount so it's a bit more accurate. That's good. Jot down another null. Call this out call. Copy that. We need to bring in a static object. Our sop path is at null. And we're doing volume sample. Next, we need to merge it into our simulation. And we need to do it from left to right, because dops read merge nodes from left to right. We can see we got it in. Now, to really know if it's working, we'll uncheck display geometry and check collision guide. Okay, so it's importing correctly. So if I press play, you can see it's now colliding with the geometry. Next thing, I want to play with the dissipation. Let's bring that up. All right. I think maybe a value of 2.5 would look good. Yes. Next thing up, let's break apart these shapes, because it's, it's very thin, so it's not really billowy, but you can definitely see it doesn't really have that interesting of a shape in all its edges. So, let's move this stuff over here. I'm going to do a few forces here, but the first one I'm going to do is a couple of gas disturbs. And right off the bat, I'll just plug this into forces. And what this does is, well, it breaks up the shapes. And obviously, that's way too much. Make it block-based, because I think that looks better. And let's bring down the strength to something like maybe 7. We're getting something a little bit better here. I think that looks good. So, we'll do that. And we'll also do some gas turbulence, which will add turbulence to our movement. Kind of hard to see it now, but if I bring up the scale, maybe the swirl size, you can definitely see what that's doing for the sim. Bring down the swirl size. And we'll bring down the scale. We don't want it to override our velocity too much. We just want to add some extra movement. So I think that's good. I think we'll do another turbulence. One with a little bit bigger of a swirl size and maybe smaller of a scale. I think that's looking pretty good. And then we'll merge our disturbance into there. Save the project. And I think this is looking pretty nice. Maybe I'll try disabling this turbulence. Just so we get more movement over here. Now it still kind of looks bad, so we'll increase resolution again. Now you can really see what we're going for here. So now I'll set the start frame to -10. Let's try -20. If I hop in, you can see it already looks like that. All right. Next thing we want to do is we want to take a DOP import fields. Drag the DOP network into here, asterisk smoke, asterisk, which will allow us to bring it in. We need to import fields, so let's bring in our density. You can see our density is right here. Now, we don't actually need the density, we just need the velocity. So we'll take vel, and yeah, it looks different, but it is the same thing. And we don't need to actually see it, so we'll make it invisible. And now, let's just cache this, which, if you notice my memory input here, see, Houdini is caching 5,000 megabytes, almost 6,000. So that's 5, almost 6 gigabytes of my RAM. And that's because all its data, when you open any software, it doesn't have access to your disk space. It only has access to your RAM, and it needs that RAM to store data on it so it actually works. Problem is, for example, if we're doing a really high resolution simulation, once we close Houdini, all that data on the RAM disappears, and then we have to resim it. But by using a file cache, we'll name this smoke val, we can save all that data from disk, like to our hard drive, and we can just load it, so we won't have to resim it. It does break proceduralism, so if you make any changes above this, so any changes to the simulation, you will have to recache it, but it saves you a lot of time when you're working on things. It also just helps store data onto just a better place to store it, so it also speeds things up. Okay, so one thing I forgot to do that I didn't realize is that I also need to try to make this go down. So I'll go to a smoke object, go to fields, and we'll just set a -1 in the wind tunnel direction. Now, if we play the simulation, you can see that it's going around, but it's also trying to force itself to go down as well. So we get a little bit of a mix of both worlds. What we were doing before. It's all trying to go down. Press play here. Maybe we need to make this a bit stronger. I think this is a pretty good result. I'll dial down the effect just a little bit. I want to say like 1.65. Okay, yep. That's looking pretty good. So my mistake, I completely skipped over that. So now we have our velocity. Great. But how do we make the portal? Well, That's where the next part comes in. We're going to take this circle, do a polywire, right? And I'll just disable lighting for now. Take this polywire, and we'll bring it scale down, especially since we don't want it to be clipping through this. Right? So I think I'll do like 3.5. Seems to be a good number for that. And now, we need to scatter a bunch of points on this. So we'll just drop down a scatter node. I'll turn off relax iterations. And just for now, we'll do 10,000. We will need more. I'm going to hold down, click on this, and then just go to pixels, which gives a more accurate representation of what our render would look like once we're done with this. Next thing I'll do is I'll do an attribute noise, which by default is on color. I'll set this to 0 centered, bring down the element size, and this will give us our now color. We'll render it like this, and we could change the color in post if we want to. So with that, I'll increase the amplitude here. And maybe I'll have it on 0 centered. And I'll do an attribute blur. I'll uncheck pin border points and change it to proximity. And I'll just bring up the blur and iterations. And what that's doing is causing these particles to be a little bit more closer together. Right? And we have that. What we'll do now is drop down a pop net, which is the same as the dot net, but it already has our particle solver in here. We'll turn off the guide and we'll say this all points. We can delete this, and now we'll get a pop advect by volumes. And we'll paste our out. Nope, not a collision. We need our vel. Alright, so if I press play, you see, this is what I'm getting. Looking pretty good. We could change a couple things. First off, let's change the life expectancy to 1 with a variance of 3, which just means it might live 0.3 less or 0.3 more than 1. Right? So they're dying pretty quickly. But our reference shows that it doesn't really go that far, right? So let's bring down a life expectancy more. And I think that is good. All right. We're getting some step in here, right? So we'll need to fix that. All right, so if I go into pop effect and click on this use expression, I can make some adjustments. So I can say the vel scale is multiplied, so the velocity scale is this. We'll do a fit, and we'll fit the age from like 0.3 to 1 between 0 and 1. And what this will do is, well, that seems to be too much, so let's try decreasing this number until we get something good. No, I made a mistake. So like 0, like 0.3 to 3 and 1. And that helps fix out stepping issues. It does, however, make it go more straight. Trace the vector method to trace midpoint. And instead of update force, we'll do update velocity. And that pretty much fixed our issue there. Next thing is we also need to have this collide as well. So we'll bring down our static object and merge. Got a collision again. You can see it's colliding just fine with it. Still going a bit far. Let's make it live a little less. I think that's pretty good. Let's change this velocity event to 0.8 so it's more accurately taking the velocity. And this is great. Problem is, we only have like 108,000 points and we need several million. Right? I will increase the sub-steps a bit. That helps a little bit with the particles, but it also just kind of gets a little bit more accurate sim as well, even though the step really isn't needed in our case. It also helps with stepping. But I think this is looking pretty nice. But we do need to scatter a lot more points. Let's start by scattering 1 million every frame, right? And this obviously slows the simulation down by quite a bit. We have 19 million points. We'll still need more. But as for right now, I do want to make some adjustments to the sim. I do want to change this value a bit. So that's more of the look that we're getting from this versus what we were getting before when the value was 0.3. It just looks a little bit better. Next thing we want to do is we'll do some post attribute blur, right? We could do it in sim, but I'll just do it outside of the sim. Right off the bat, we're getting a pretty decent result. I don't think we need to tune it in any more than that. Next thing we do is we'll drop down a wrangle, and I will just select a preset I made from a course, compute particle density. If I drop down a color node, and do something like this, and I get the density. That was meant to be blue. And this needs to be reversed. You can see what the code is doing. So basically, what we're doing here, if I drop down another wrangle, and I'll just do like a random PC fine operation, we can see the one that we're doing is we're performing a proximity query. So we need to create an array of points, which is a list of points, and we find it from the file name, so it will be just the first input. We need to grab the position, then the position attribute, and then we need to create a max distance and a max amount of points that it will grab. That's what it's doing here, and we're creating PTS as our array. Then we're saying, all right, well, we'll create the density, and we'll measure the length of those points. So again, we do length. Yeah, sorry, this one returns the length of an array, right? And we're finding the length of that array, and we're dividing it by a total right here. This effects density is just basically setting the color for when we use this as an extra rendering image, and we'll go over that in a bit. But basically, if I start bringing down this distance, I'm getting less and less of those particles in there. And this is going to allow me to grab, only the most dense areas. And we can use that in comp later on to help us achieve a really cool effect with what we're doing. But as of right now, I need to create more particles. But first off, let's also make sure the start frame is -20. And we'll reset simulation so it can calculate those first 20 frames. And it's not doing anything. What is Oh, you know what it is? I forgot to change this. I needed to calculate the velocity for those first 20 pre-roll frames. I didn't do that before. So I'll save this and I'll be back with you in a second. Okay, so I cached the sim. And as you can see, there's around 72 million particles, which is a pretty good amount. You could go higher. I wouldn't go much higher than 100 million, and even then, you might not need it. I will point out a couple things I changed. Particle count was 3 million. In the pop net, I set the scale time to 0.5 because I felt like it was moving a little bit too fast, so that helps slow things down a bit. And in here, I brought this from 0.8 to 0.9. Trying to remember if I changed anything. Yeah, okay, so I changed this from 0.4 to 0.5 right here too. So you just live a little bit longer. And before I cached, I deleted every attribute except for the color and the velocity. Then I cached that. I also changed the value of the distance here for our density. Next thing I want to do is that if you look at our reference, you can see not a lot of it is going inwards towards the portal, right? So I want to go in here and try to create a AOV like the one I've created here to try to filter out some of those middle areas. Okay, I'm back. Another thing I did is I did transform particles up, because if I view this, since it doesn't want to load, you can see it phases through the geometry pretty well, even though it was colliding with it. And that's just because the VDV isn't entirely accurate to the geometry. As I was saying, I want to create an AOV that kind of filters out some of the inward areas. And I'm going to use it in comp. So what I'll do is I'll copy this circle. I'll bring it down over here. I'll switch this to closed. Then I'll do a poly extrude. Check output back and adjust this to give it some thickness. All right. Next thing, I'm going to grab a transform. I'm going to scale this down by quite a bit. Then I'm going to jump to another wrangle node. Plug this to the second input. And obviously, right now it isn't going to do anything. But if I do another preset, compute distance, I'll explain to you what this does. Alright, so essentially, what I'm doing there is I'm creating a variable, and I'm using XYD dist XYZ dist, which will it'll find the distance from a point to the closest location. So I want it to be the first, one input, which is the second input, because it goes 0, 1, 2, 3. And I'm looking for the P attribute, right? Then I'm saying the same variable, I will fit it between itself, between a minimum value and a maximum value, and I'll flip the order. And then I'm doing the same thing over here I do with the density. And what that is going to do, so I drop down a color node. And I wait for it to cooperate with me. I'll set it from ramp to from attribute. And I'll do it effects dist. Why is it? Okay, so it turns out I just had this templated the entire time. I didn't realize. So yeah, we'll still fit this between 0 and 1. We don't want to reverse it. For this in particular, though, there are times where you'd want to reverse it. And once this calculates, you can see that, yeah, it's not moving a lot. So let's maybe increase this number. Right? And we're looking for like these inside areas to be more black. Right? So more we increase this number, the more black the inner areas will become. And that's what we're aiming for. And it's all based on the distance between this and maybe I do still want to reverse this. I'm not entirely sure, but let's check it out. Let's make it down a little bit more because we don't want to include a circle. We just want these little bits in here to be in it. Okay. Okay, I do still want to play that attribute buff. So let's try. Let's find everything back in. Let's do a fit range unclamped. Plug this into color. Do 1 and 0. Which will inverse this, but maybe we'll bring down source max. Or, maybe actually bring it down. There we go. All right. That's what we're looking for. Try 0.1. Okay. I think that is good. Yeah. So that will be our effects dist AOV. So the next step is shading and rendering. Okay. So we'll name this null out particles, right? One thing we'll do right before is we'll do a trail sop. And we're not going to plug it in next. We're going to compute velocity. As we know, we do have velocity coming in, but it's always good to recompute it, like post-sim. And the reason why we're doing this is because we want to render this with motion blur, which will take up rendering time, but it will, help out overall in the process. Okay, so if we click this button right here, you can see a basic representation of what our velocity looks like. Not that you really see because we have 72 million points, but you get the point. So I'm going to copy this null. I'm going to go out here. We're going to create another geometry, and we'll just call this RNDR part for particles. Now I'll drop down an object merge, paste the null into here, and select this to be into this object. Now we almost have it ready to set up. All we need to do is go into this, go into render, sampling, velocity blur. And we'll need the material here as well. So I'll go to the material network, and I will work on the material. So we'll drop down a principal shader. We'll call this magic shader. Set this to white and not to 1. IOR, roughness to 0, all that, reflectivity 0. We don't want any reflective properties because in all technicalities, it's going to emit its own light. Next thing we're going to do, we're going to right click, allow editing of contents. We can go in. We need to bind in our AOVs, the ones we created. So we'll bind in a vector. This is effects density. And we'll bind export as the same name. This allows us to put it into the shader so our render can recognize that it's there. And you'll see what I mean in a little bit. So do effects dis. This will be a float. So we don't need to change it to vector. Bind export as effects dist. Right? I'm going to click and drag this shader into the material, and we'll disable these lights. I'll drop down a mantra node, which is Houdini's one of Houdini's native renderers. I'll call this magic or RNDR magic. Go into objects. We'll take off the candidate objects and just force our particles. Now, just for right now, let's see what this looks like. And as you can see, this looks like absolute shit. This looks like a bunch of spheres. And what we need to do here is something that I was going to get to when this happened, is we'll go back here and we'll do another wrangle. And we need to change the scale of each particle. So we'll do at p scale equal to fit 01 random from the ptnum. And we'll go min max. We'll set this to really low numbers like 0.0002 and 0.0005. Go back to render. And we will try this again. Now we're getting a result that looks a lot better. And over here, we can't really change much, right? What they will do is click on this and click on that. So next thing we need to do is bring the samples up. So far, this is looking a lot better. You can see we get this nice smooth look to everything. The next thing we need to do is we need to enable motion blur. Okay, so it is being really slow, so we'll just disable the motion blur. We'll just do it in post. Again, not the smartest idea. Preferably you wouldn't do it this way, but I don't want to have this rendering for 2 days straight just to get my render. So I'll bring the samples back up. Next thing we need to do though is we need to go over in images, extra image planes, and we need to add our AOVs. So first one is effects density. And the second one is effects dist. You see they will pop up on this thing right here. As long as we did everything right, we should have those ARVs. This is a float type. That's a vector. All right, so we got our effects density. We're not getting our dist. Effects dist. Do it. Oh. Well, that's why. I plugged the wrong input into it. All right, so one of the last things we're going to do is we're going to go to Render Magic. We'll go to Objects. And we'll do Forced Matte. And we'll probably create that path, shouldn't I? So we'll go out podium. We create it. Object merge. Paste the material back. And over here, objects, force the render podium. We'll also force phantom our particles. And what we'll do with that is we'll go into material and we'll bind in the CD, so the color, which is a vector, and we'll plug that into the emit color. For some reason, using emission makes the AOVs not work, so I'll have to render these two separately and not at the same time like I could be doing. And I'll set this value to something like 10 or 20 just to get some nice reflections on the podium itself. But we'll go back over here, and for the magic, we will force matte the podium, which will basically cut out any parts of the particles that are wow, stroke. It will cut out any of the particles that are currently being obstructed by the podium. As you see, that took around almost 2 minutes to render. If we zoom in, you can see everything here is nice and smooth, and that's thanks to our particle count. Again, if I go to scene view, we're looking at like 70 million particles. Quite frankly, more than enough, but I also, sometimes it's good to go on the higher end. Again, you wouldn't really want to go above 100 million, but like 70 million is good and all that. But yeah, we're looking at almost 72 million particles there, and we're getting this result from it. So a couple things. First off, I did a test render, and it turns out that the color we set here wasn't working very well, so I had to create another attribute noise to change the color a bit. All I did was do basically the same thing, but instead of on 0 centered, it's on positive, like it was to begin with. So just, if you haven't done all of these steps yet, make sure you do this pre-sim. It's not a huge deal doing a post-sim, but it's always better to do a pre-sim. Other thing I forgot to mention is that we need to render this as an open EXR. When we do render it, we need to name it, do $F, and then .exr. You have to write it like that. This render thing can be anything, but you need $F.exr for it to render properly. That being said, I will get back to you when it's time to comp. Okay, so one more thing I forgot to mention was to set up some things for the render platform. Again, I did set up putting the color into the emit color. It's saying this, I set it to 50. The other thing I did is under render platform, extra image planes, I selected direct lighting, indirect lighting, and combine emission, which gave me all of these. One of the ones we're going to use is direct emission, direct diffuse, reflect, indirect reflect, and all emission. Those are really the only ones that show up here. So those are the ones that we'll use. All right, let's see you in comp. All right, so now we're on our last step, which is compositing. As you can see, we got our full render for the particles. Looking really nice. Love how smooth everything looks. And we have our pedestal render as well. So let's start on the compositing for this. Now, obviously, in our reference, the teleporter is purple, but it's not purple here. So the first thing we'll do is we'll press G, drop down a grade node. And I'll click on this color wheel right here, and I'll just drag this more towards the purple, something like this. You can see the reason why we have it multicolored, because we get this nice natural kind of randomness to the color. It's not all the exact same color. Next thing we do, we drop down a layer contact sheet. We can see the different layers we have. Show layer names, we have our RGBA, effects density, and effects dist. Now I did some test rendering, so I test compositing with the effects dist. It's not exactly working the way I'd hoped, but I'll still show you how it can work. But for right now, let's get a shuffle node down, which will allow us to get access to these AOVs. So I'll just click on here, effects density. Now we want the red areas because the red areas are the most dense. So we'll just take the red, plug into the green, blue, and alpha. There we go. I'll press G for another grade, and I'll point the mask over to here. I press Control and just do that with the line so it looks nicer. If I bring up the gain, it's only bringing up the gain for the areas that are most dense, which is perfect. Another thing I like to do is I will merge it over on top of it so we get these nice little white areas, but I'll bring down the mix a bit, you know? So I'll bring it to like right around here. Do another merge. This time I'll set it to multiply. So the most dense areas are the only ones that show up. That's fine for now. And now I'll do an EXP glow. Now I can't give you this. What I can do is just point you to something that should work the exact same. I haven't tested it out, but it's an exponential glow, just like the one I just put down, but with more settings. So it's probably even better than this, but I haven't tested it out. Anyways, you get this. If you bring down the fall off, bring down the size as well. Bring up the fall off a bit. Get this nice glow. We could do another EXP glow. You can move it bigger. And then we'll merge these together. We'll do it plus. And then if we merge this back over to here, it's on top of everything. Which so far we've gone from this to this. Already looking great. Another thing we'll do, so just drop down the glow. This is the native glow that comes with Nuke. Don't think we need to change those settings. We'll drop down a keyer. Now automatically this is set to luminance, which is the brightness. And what we could do is we can press C drop down to color correct, use that keyer as a mask. And what that's going to allow me to do is if I bring down the saturation, I'm bringing down the saturation of like only the most bright areas. So if I disable this mask, I'm doing it to all of it. But now, I'm doing it to only the brightest areas. Press play. This is what we got. Now I'm going to play with the glow a bit. All right, I brought the size all the way down. So now we get these bright areas kind of in all the strings as well, which is really nice. Another way we can help with that is if we take this and we do a grade on it. And I just bring up the gain. And use that on the multiply. Doesn't quite work the same, but you know, obviously that's too much. But yeah, this is what we get. And I'll probably add another EXP glow. That was like the one we had earlier. Small size. More like this. And we'll merge that with it all. And, you know, bring out saturation a bit more. Disable and re-enable. You can see what we're doing here. And then we could drop down a motion blur node. This as the source. Right off the bat, you can see it works. I want to bring up the shutter samples maybe like 7. And I'm just testing out different settings for the blur. I think that's too much. But I'm just testing all these values. Bring up the saturation a bit. One final thing I could do to this is, add a final grade. Really try to dial everything in. I think it looks better without it. And keep in mind, we could still go back to this first grade and we could change the color. Right? We could change this to any color we want. But the reference is purple, but you can literally recreate any one of these teleporters you want just by doing this. Or you could even make it, multicolored by disabling the grade and maybe turning down the glow in all the areas and maybe bring up the saturation a bit. But what we have here, I think, is looking pretty good. And when we disable the motion blur, we can definitely see that it's doing doing pretty well for this. It works pretty well with most things, but do keep in mind that it's not real motion blur, so there's gonna be errors, and at the same time, if you're doing like a helicopter, it won't work properly. You have to render it with actual motion blur in your 3D software for it to work, because otherwise it just won't look right. But you know, in some cases, again, preferably you render with motion blur, but you know, this is looking pretty nice. So overall, I'm happy with it. All right. Well, now we need to worry about this guy. All right. Well, first off, let's do that layer contact sheet again. We can see which ones don't work, right? So we need the all emission, direct diffuse, direct reflect, and indirect reflect. All these other ones don't show up. Great. So let's shuffle all these out. The reason why we do this is that we want to separate all of these into its own, you know, we want to separate the diffuse and everything so we can make adjustments to one specific thing without affecting everything else. Because if I affected the all emission combined with everything else, I'd change the color with everything else. But we only want to change the color of the emission. And obviously, some things might need more adjusting than others. And they might need different types of adjusting. Okay, one thing I forgot to do earlier, which I'll do now, is I'll take the shuffle, bring out the effects disc. We actually don't need to change anything there. It's already black and white. Then over here, I will multiply it by this. I could do a grade. Try to bring everything back. You know, but overall, it's not exactly working the way I intended. And overall, the grand scheme of things, it didn't end up being that much of a problem in terms of things going inside as I thought it might be. So it doesn't matter all that much. Anyways, we have all of these separated. First thing is we'll just copy this grade over onto the emission, and there we go. Another thing we could do is, as you can see, there are a lot of white areas here from the glow. So what I can do is do that same keyer and color correct that we did earlier. To bring over those white areas onto this. Right. So let's start merging these all together. All right. That thing we'll do is we'll take a grade here, bring the gain all the way down. Then we'll just merge this back so we can get our alpha channel back. We kind of lose it in the shuffle. I think there's another way of doing this, but I don't fully remember. Looks like we didn't lose the alpha with our particles, though, so that's good. All right, so let's make some adjustments. So, for the diffuse, let's drop down to grade. Like that looks pretty nice. Maybe I'll bring this back to 0 and that back to 1. Over here, let's take a grade. Let's just bring the gain up and multiply a little bit. Makes it a bit more visible. Over here, could do the same thing. Makes that more visible. And I think I will also do a grade right before everything else on the emission to bring that up as well and to make it more visible. Maybe I'll bring up the saturation so you can still see it was purple. And over on this grade, move it over a bit so it's more of a purple color. All right, great. Now, let's merge this on top of this. Under. There we go. And now, one thing we'll do is we'll add some grain. I think what I'll do is I'll do the grain separately. On here, we'll just bring the intensity down. And then we'll do another grain on our render. And we'll bring the intensity down for this as well. Very subtle, but it's there. Okay, so this is the final effect. And I should have said this at the beginning, but I want to just let this be known. I am in no way a professional. There are definitely better and more interesting ways of creating this. If I spent more time on this, I probably could have made something better. And there's definitely people out there who could have done a better job than me. I'm just still learning. But overall, I am happy with this. So the final thing we'll do is we'll press W for right node. Export this out as an MOV. We'll do motion JPEG. Raw data. MOV. JPEG. Best quality. We'll export this out as whatever we want to name it. Save. Press render. All right, so what I had to do was go over to color space. Need to select the not the CC, the CG for ACs. Then swap over to display. And now, if we render this again, so this is the result that we get. I hope you enjoyed this. Again, I am not a professional, so do take a lot what I said here with a grain of salt. There is a lot of improvement to be made with this, but at my current skill level, this is what I'm able to create, and I hope that you enjoy this tutorial. I'll see you next time.